So if you take a look at your extension page, you're going to see there are some problems that actually look significantly more complicated because there are going to be logs in more than one place. Kind of a good news, bad news thing. The bad news is it looks more complicated. The good news is it actually isn't. So here's how this is going to work. When you've got logs in two places, here's the trick. You separate them. So one log on the left of the equals, the other log on the right of the equals. And then the general idea is this. If log base 4 of this thing equals log base 4 of that thing, then basically this thing and that thing have to be equal to each other. We can just not ignore the logs, we're going to remove them, but we're going to focus just on what's inside being equal. Now, the way you remove the logs is by taking into account that logarithms give you exponents, right? So this whole thing is going to give us a number. That number is the exponent you put on 4 to get this. Same thing on the other side. This whole logarithm is a number. That number is an exponent. The exponent you put on 4 to get this. So let's just make both of these exponents. There you go. Use exponentials as inverse operations. At this point, just like add and subtract undo each other, just like multiply and divide undo each other, just like squared and square root undo each other. 4 to the power log base 4 is just going to leave you with what was inside the logarithm. 4 to the power log base 4 is just going to leave you with what was inside the logarithm. So then, let's solve what remains. Let's get our n's together. Okay, so we have 5, that'll be plus 1n equals 1. Subtract the 5, n equals negative 4, and there you go. You got your solution. Now, it is a little bit more important to check your answers here. When you've got logs on both sides, extraneous solutions are much more likely. Here's why. I'm not allowed to have negative inputs to my logs. I'm not allowed to have negative inputs to my logs. It's possible that where these two things are equal, when I put this n in, I get a negative number inside. That would mean that in this particular case, this solution actually doesn't work. Here's how you check. Just focus on what's inside the parentheses and make sure you get the same positive number on both sides. So I think n is negative 4. If I do 5 minus 4 times that n, just make sure it's some positive number. On the other side, make sure you get the same positive number with what's inside these parentheses. Negative 5 times n plus 1, negative 5 times the n, I think it is, plus 1. And look at that. We got the same positive number both times. That means that we have done things okay. If you get different numbers, that means you made a mistake. And if you get the same negative number, that would mean it's an extraneous solution that should not be included in your final answer. Let's go again. Same idea as you're working through. I'd like you to pause, try it yourself. If you get stuck, unpause, and then just go back and forth. You know how this works at this point. So the logs are already separated. Make them both powers of, let's go back to our highlighter here. Powers on 2. So 2 to the log base 2, those undo each other. We're left with just what's inside the log. Same thing here on the other side. It's a quadratic, so let's get everything on one side of the equal sign with a 0 on the other. And see what we got. So 0 equals, this would be 1x squared minus 6x plus 9. You can solve this quadratic formula, factoring. You can complete the square if you want, whatever makes you happiest. Here, though, I'm going to use factoring. That's, to my mind, the easiest way. 0 equals, it's just x minus 3 times x minus 3. So the only solution here, potential solution anyway, is x equals 3. Because 3 minus 3 would give me that 0. You need to check it. Sometimes with a quadratic, you'll get two different answers. One of them will give you the same positive number both sides, but the other one maybe gives you the same negative number both sides. You need to check those solutions and include only the ones that give you the same positive both sides. So let's make sure here, if we put a 3 in for our x's, we get the same positive number both sides. So negative 9 plus 3. I think 3 is what x is to the second. So a positive 18 on the left. Let's make sure we get a positive 18. If I do 4x squared minus 6x, 4 times 3 squared minus 6 times 3. Same positive number, so that means we do in fact have a solution. So check them. Sometimes they're going to work. We've seen that happen here a few times. Sometimes they'll give you the same negative. It means it doesn't work. So be mindful of that as you're going through.